Hi, so in this screencast, we're going to take our analysis one step further. Last time we were analyzing the spam data using the keras package in R, and what we did is we did some training using this for loop, where here we defined n splits equals 10, and then we did a for loop over those 10 different splits. For each for loop, we're defining a model with 100 hidden units, and which is predicting a single binary output. We're using binary cross entropy loss, SGD optimizer, that's stochastic gradient descent, computing the accuracy metric at every epoch, and then we're fitting the model on the train x and y data um, using 100 epochs and a cross validation split, which includes 30% validation, 70% subtrain. And what we saw is that that code gave us, for every one of those iterations of the for loop, that gives us one train validation error curve. After that, we save all of those validation error curves in this data table called split metrics, and then we compute another data table called split means with the mean and the standard deviation of all of the validation loss values. And then finally, the number of epochs that we choose is the minimum of the mean validation loss. And so here in this tutorial, what we're going to do is a little experiment to see how that value changes as we change the number of splits here. So let's do that. So for the number of splits here, we defined it as a constant 10. So actually, let's go to the top of the code first. Starting the keras library. Let's evaluate all of this code that we need to get to that point. Okay, and now instead of n splits always being 10, let's do 4 n splits in 1 to 20. And so what is this going to do? This is going to, well, I don't know, actually, so maybe that's a bit much. So let's do seek 1, or I don't know, let's do 1, 5, 10, 20. So we can see some general trends about how this depends on the number of splits. I don't know. Actually, here, let's do a few more. 1, 2, 4, 10, 20. How about that? Yeah, the goal is to kind of show, I mean, the expectation is that, the more splits you do, you better idea you have what the validation error looks like. You have a better estimate of the validation error, and you should have a better estimate of what the best number of epochs is. So the idea is that hopefully we're, when we're doing fewer splits, it's going to take less time, but maybe you get a less accurate model. We do more splits, it's going to take more time, but maybe we get a more accurate model. So let's see if that's actually true in this data. So here what I'm going to do is inside of this for loop here, I'm going to move this split metrics list outside. And after that, inside of here, I'm gonna, so here we have a new variable n splits. And so here what I'm going to do is I'm going to store these data as with a key based on n splits now, in addition to split I, which is the split number. And then we're going to be able to summarize all that data later. So here, let's perform that computation. See what happens. I think it's taking a little bit of time maybe before it shows any output, because here's loading Python keras. So now it's doing the computations, running. It's good. So basically, we're going to have to do a bunch of different runs for each number of splits. Every time it's going to fit that model it's going to be plotting the train and result validation curves, and then we're going to do this and saving the result to this split metrics list. So here, let's already start working on the code while we're waiting for that computation to finish. So here I'm going to keep this code, which is split metrics do call r-bind split metrics list. And so here, instead of doing this mean just for every epoch, here let's do it for every epoch and every value of n splits. So that's going to give us a different validation error curve for every value of n splits. Near the min dt here, it's going to be which mean validation loss. We're trying to find the validation loss value, which minimizes, which is minimal. And here we're going to do that by equals n splits. So we get a different value for every value of n splits. After that, we can do maybe edit our ggplot code. So here we can, so maybe instead of, here we have a geom ribbon and a geom point and another geom point for the different things that we want to display. And so here, maybe instead of that, we can make a facet grid plot which shows all of those values in different, all of those curves in different panels. So let's try that. So how about facet grid? And splits, so that's going to give us a different panel going from left to right for all of the different values of n splits. And here I might want to edit my, here we have a geom point for drawing the min dt data set, and that's the number of validation iterations that minimizes the loss. So we might want to add another geom text to kind of emphasize that. So let's do same everything here, except for we're also going to add label equals epoch. So that's going to draw the epoch number next to the minimum, so we can see what is the minimum number, which number of epochs minimizes the loss. After that, we can do v just equals how about 1.5, and that's going to mean that we're vertically justifying the text so that it's a little bit below the point that we're drawing over there. Okay, so we're still waiting for the computation. One thing that we could think about doing when we're doing a long-running computation like this is, maybe doing the computations in parallel. So, that's my typical rule of thumb. If I can just write the code like this with for loops and I don't have to wait for anything, and that's fine, that's what I'll do. But then if I have to start waiting, I start to think about how I might parallelize the code. And so, yeah, we could think about doing all of these computations here in parallel. Or we could think about, just rewriting this. Yeah. So, one optimization that we could do is to, instead of computing so here we have two for loops, right? And the first one is doing, the number of splits. The second one is going to do all the model training from 1 until that number of splits. And so that, yeah, I mean, so basically all of the splits when we're considering 20 splits are going to be different from the splits that we're doing when we consider 10 splits. Another way to do that would be to just consider, all of the splits from 1 to 20. So instead of having these two for this, I mean, so we could consider 20 different splits, but then we could just, compute the best validation loss on a subset of those guys, either all of the 20 splits or the first 2 or the first 4 or the first 10, etc. Right? So that would be one optimization that we could do. So let's try that. Um, so to do that, maybe we can change this n splits here to max splits. How about max splits equals 20? So yeah, I mean the reason that way that would be beneficial is because then we would only be doing actually 20 splits rather than the sum of all of these splits, which is about 35 or 40. So it's about maybe about twice as fast if we do it like that. So already we can think about doing that. So how would we edit the code to do that instead? So we would do for split I or in 1 to max splits. Here, and so then what we're going to do, here, well, the code finished processing, so let's let's look at the results now before we talk about that refactoring. So here I'm gonna compute the metrics. Here I'm gonna compute the means. Here I'm going to compute the min and then make the ggplot that we did. So here are the different curves that we drew, which are more or less what we expected, except for here with the min, I think we need to change the code a little bit. Instead of putting which min here in the first argument, here we need to put it in the second argument. Dot SD, that means the subset of data that corresponds to the by subset that we specified over here. So let's do that. So then we have, then we have a bunch of different estimates of what the good number of epochs should be. So with only one, with only one split, we choose 45 epochs. With 2 splits, we're choosing 65. With 4 splits, we choose 45 again. That's kind of serendipitous. With 10 splits, we choose 52. With 20 splits, we choose 49. So how do we compute which one of these is like the best? They look to be pretty similar in terms of validation loss, but the real test is if doing that many iterations works on the test set. So let's try that. So in this code we saw in the last tutorial, what are we going to do? We're going to take the entire train X and Y, and we're going to run that for a certain number of epochs. So here it's 52, 50, so yeah, I guess we should have to take the maximum of these guys, right? So if we look at min dt epoch, take the maximum of those guys, that's 65. So we have to run our algorithm up to 65, and then we'll compute the error on all of these other guys. So let's do that. The maximum of min dt epoch. The other thing that we might want to do here, we specified validation split equals 0. But actually, so if you look at the documentation here, let's see, keras fit. Is that going to come up? Yeah, so there's still not a super informative documentation page there. But if you go to the project description, here we have documentation for fit. And here we have, you know, validation. Validation data equals null. So let's see what that looks like. Validation data, data on which to evaluate the loss and any model metrics at the end of the epoch. The model will not be trained on this data. This could be a list, xval, yval, or a list, xval, yval, val sample weights. So let's do that. Because then what we'll have is we'll have a computation of what is the test error for all of those different epochs that we were looking at. So let's see. So that would be validation data equals list x test y test. X test mat y test, I think. Right, this is what we were using before. But now we're doing it here in validation. So it's kind of confusing here because here this is going to be a way that we can get the test loss. So here we're specifying the test set for validation data, but we're not going to use, so usually we use the validation data for computing what is the best hyperparameters, regularization parameters, or here the number of epochs. But here we're using this kind of just for convenience because we already know what is the best, value of epochs from our analysis here of the validation error earlier, using our different number of splits. So now here we're just using this to compute the test error for all of those, or the test accuracy for all of those different values of epochs. So let's see what that looks like. So, so here we do, oops, that's not working, I need a comma. So here again, we're training the model on all of the training data up to the maximum number of epochs that we learned, which was the best, using our different numbers of those splits. And here now what we're going to do is, let's use this same idiom that we had before. Right, where is that? Here, do call data table, result metrics. Let's try that. That gives us this data table of all of the validation, loss validation accuracy that we saw before. So let's call that test metrics. Then test metrics, we want to add a column called epoch. So then we can do a join with this min dt, right? So min dt on equals epoch. And so what is that going to give us? So this gives us the different values for the accuracy for the different numbers of epochs. And so in this case, actually, there's not much of a difference. So whether you do one split, you get about 92% accuracy. You do two splits, get 92.5% accuracy. You do four splits, you get 92.1% accuracy. 10 splits, 92.5. 20 splits, so they're all about the same, hovering around 92%. There's not a clear trend about the accuracy increasing with the number of splits in this particular data. So that's kind of not confirming our hypothesis. So actually, it's just as good to do one split as it is to do 20 in these data. So I think that's enough for this tutorial. Thanks for listening.